Coisa leigo. Okej, validation. Pamiętajmy monitorować.
Good morning, everyone.
Hello. Good morning.
Good to see everyone here. How are you doing today?
Good.
That's nice. Arion, where you are from? You are mute. Unmute, please. You cannot unmute, yeah? Just a second. Now I can hear you.
Okay. So, sorry. Nice to meet you here.
Nice to meet you too.
Pleasure. Yeah. And it's a nice weather here in Albania. I don't know there.
Sunny Albania. That's good. That's good. Yes, I know that Albania today will be the most crowd company here. So that is good to see and good to hear you.
Nice to meet you here and waiting to hear also from Rosti. We had a very good meetings. This late, the latest meeting that we have done, also with Vladimir and the engineer, and also before training with Rosti and with Andre. It was a pleasure to hear from them.
Yes, that's good. That's good to hear. Thank you for your feedback. Yeah, we are doing our best.
Yeah, and I think it's the best restart that you are doing now, so it's very good.
That's great. Okay, we will wait a few more minutes.
Hello.
Good morning. Good morning, Rosti.
Today we have so many people with cameras on. This is nice. This is very nice. So good. Hello, everyone. Today we have another topic. So before we jump in, I will do a small introduction of what we do in general and what we are going to do today. So first of all, let me introduce myself and let me introduce Oksana. So my name is Rostislav. I am responsible for product development at Ecosoft. And my background, I am chemical engineer in water treatment with the 13 plus years of experience developing filters, making technical support, and also making trainings. So for the last many years, we have made so many trainings for our customers all around the world, and actually sharing knowledge and helping people to make water clean and pure. This is one of our main activities. So today we will talk on the commercial ROs, and we will talk with Oksana about selection tips and some technical details on how to select commercial RO system. Oksana is my colleague. Oksana, let me introduce you.
Yeah, you're welcome,
so
Rosti.
Oksana is a head of customer service. So Oksana is doing her best so that you receive your orders in time. And also Oksana have received many questions from you. And many of those questions Oksana will address to me today, so that we discuss not a theoretical tips on how to select, but we will talk on the questions you normally ask on the everyday basis. And so our agenda of Friday is that we have this kind of meeting every Friday. Every Friday, this time, we talk on each very detailed topic. You may influence this topic, so you may give your ideas and what you would like to talk next time or in the future. I cover this topic with some demonstrations, so with some case 10 or 15 minutes, and then we have so you may ask questions in the way you like. So you may ask questions by raising your hand, writing in the yes, now we are okay. Writing in the chat. Also, you may ask questions. Just ask. So it is always nice to have a discussion. So I will start today also with some new information. So all Friday talks actually we record, and if you go to Ecosoft channel in YouTube, so you will find the recordings of the videos, so you may see them online later. And also I wanted to show you that if you go to the playlist here and then you select English, you may see many videos that we have made by us to discover and to explain many topics. So you may find videos on the residential arrows, on the commercial arrows, and today during the talk I will also cover one of the videos that we have. But I think, Oksana, can you see my screen or no? Yes.
Yes, Rosti, I can.
Yeah. So today I will start with our regular job, what we do every day. So normally when we select, so we always start with the water test and the water demand. So now on the screen there is a very good request and very good formed and very well, I would say, very well arranged request on the selection of the commercial arrow. So this is the this will be an arrow or an arrow system and the complete technology for drinking water bottling with the demand of 5 to 6 cubes a day. The water comes from the municipal water supply. So basically, this is the water comes from that comes from the Kyiv, the capital of Ukraine, centralized water supply station, and this should be a system that will be used not 24 hours a day, but it will be used. The system should work on the storage tank. And so this is the general information, and here is the water test. So what we see, so here in the water test we have turbidity, we have quite a high color of water, and this color is the reason for the color is organic matter. So the water in our capital city, the water comes from the river, and then it is treated. And during this time of the year, in March, April, normally we have quite a high color, so it's around 40 degrees. This is the color of the water. Then the hardness is around 300. We have a little bit of iron, manganese during March and time, a little bit, and this is a total TDS. Also parameters.
Rosti,
So,
just a second, please. Ersi, do you have the question? Ersi, you raised the arm. Do you have the question?
Maybe it's something wrong, maybe. I don't think so.
Okay, then try please to.
Okay. It's okay. This is
good. So
and
let's
then
continue.
so this is the typical flow chart of the unit of the water treatment station for the drinking water, for the bottling of drinking water. So the key part, the core of the scheme, is the reverse osmosis unit. MO 65,600 that provides 0.25 cubes an hour. Then, as a pretreatment, for such a water, we use Ecomix unit. So we use Ecomix unit first of all to soften water and to reduce organics. Also, we know that it would be very nice to install an activated carbon filter. And here we use the Filtrasorb 300 activated carbon. It is a macroporous carbon to also
Rostislav,
to remove organics.
Sorry again, do you show us something else? Because we see the table with the water analysis.
Yes, you should see the flow chart.
No, unfortunately, we see the table with the water analysis.
Okay, I will switch on for a while and then I reconnect again. Just a moment. So let me share again the screen. So can you see now the flow chart?
Yes.
Okay, so I will start from the very beginning. So this is the typical flow chart and typical set of equipment we use when we prepare drinking water. We call this type of projects, we call them drinking water kiosks. The core of this scheme is the MO 6500 that provides 0.2 cubes an hour of permeate. As soon as we have iron and organics and also hardness in the water, we install the Ecomix unit before RO, and also install the unit with the activated carbon. In this case, we use the Filtrasorb 300 macroporous activated carbon. And this carbon is particularly good to remove high amount of organics beside the organic makes the water a little bit yellowish. So this is the pretreatment. And of course, before Ecomix units and before the activated carbon unit, we put screen filters. So normally it's a stainless steel screen filter with the filtration rate of 100 micron. So this is the pre-filtration. And then after RO, very often we use the dosing stations to remineralize the water. So basically we add either calcium and magnesium in the water. So this is more or less the basic. Very often we dose a little bit of sodium, I would say the baking soda. This is to change the pH, to make the pH in the range of 7 to 8, so that the water has the nice taste and meet the water treatment requirements. Then after the tank, so then the water is delivered to the tank. And then we have the pump station. After the pump station, very often we use the carbon filter as a cartridge one and the UV. And then we have the line that the water flow that goes to the dispensing area. So this is the flow chart that we very often use, and I will come back to this scheme a little later. So these are the typical water kiosks that we have in Ukraine. So very often you would see the unit, the reverse osmosis unit, the prefiltration. Yeah, sometimes we do the prefiltration with tank-based filters and cartridges. In some cases, you may see like the ones I have just shown on the flow chart. So we have 2 units before. Yeah, so mainly, as you see on these photos, mainly we use the 2-stage prefiltration, RO, and the tank. Also, the first one, this is the unit for the restaurant. a little bit. It has a larger prefiltration because it has the twin unit just before to make 24 to ensure operation 24/7. Also, I would like to draw your attention on the type of the tanks we use. Very often we use the polypropylene tanks that do not transfer the sunlight. So if we use this type of tanks, the water keeps its freshness quite for a long time, because the cheaper version is to use the polyethylene tanks that can be that can let the sunlight through, and then very often after 3 or 4 months you may have the fungi growth in the tanks. This is what we don't recommend to do, but these ones on the photo are a very good solution for drinking water applications. So basically, this is the logic behind the selection of the units. Maybe you have questions right now from our guests, and maybe we can, if not, then we could answer questions from Oksana.
Okay, I guess no questions at the moment, so I will start this. So, Rosti, thank you so much for the detailed explanation for this complex sample example. But let's start from the basic moment. So, very often we receive the question. So, for example, if customer needs the capacity of 500 liter per hour, will, for example, a MO 12,000 fit this request? What should we pay attention to avoid problems with this?
Yeah, this is so if we need a flow rate of 500 liters per hour, in the majority of the cases you can take a unit that gives you 500 liters per hour and it will do the job. However, there are many buts in this approach, and first of all, we should look at the raw water quality, and we should look at the water temperature in your area. You may give this request from Greece, for example, if the water is warmer, or you can give this request from north of Norway or from Sweden, where the temperature is normally 10 to 15 degrees all year round. And in the manual for EcoSoft units, that is, you may download it from our website. Now, Oksana, now you see my screen.
Yes,
so you may find, like on page 6 on our manual, you will find a chart that explains the flow rate. This is the unit. This is the 500 liters per hour unit. That explains what would be the flow rate at different temperature and at different feedwater TDS. So let's say we have a TDS. Oh, we hear Maria. So we have a TDS, let's say we have a TDS of 1000 ppm, the feed water, and the temperature is 15 degrees Celsius. So then we see that the flow rate of the system would be 450 liters per hour. So the question again, if we can use this unit to get 500 liters per hour, so the question would be no. Yeah, because you would get only 450. Another thing that we have, another aspect that we have to take into account, that with time, the flow rate is going down. And when we select a unit, we take into consideration that over 3 to 6 months, our flow rate may go down by 30%. So in our case, we may go to 300 liters per hour. And then for sure, this particular unit would not do the job for 500 liters per hour. And I know that sometimes it is quite disturbing when a customer asks if we can use this unit, and we, instead of saying yes or no, we keep on asking questions. What is the water test? What is the temperature? But we do this in our main goal is that you do the job from the first from the first time. Yeah. So our goal is to select equipment in the right way. Also, what we also have to take into account is that we have to know what is the daily consumption. So if the daily consumption is if we need 24/7, then for sure we have, in this case, we have to select a next unit. We should go to a MO 24,000, and this would be solution in this case. If we need only 10 hours per day, these 500 liters per hour, then in this case, I would suggest to install a larger tank and then do this job. So this is the answer to your question.
Mm-hmm. Okay, thank you. Any questions or clarifications on this comment, gentlemen and ladies?
There is a question from Dominic
Mm-hmm.
in the chat. Dominic is asking, what is the purpose of carbon filter after storage tank with RO filter? So the purpose of the carbon filter is to remove smells that might appear in the tank with time. And this is the reason why we use the cartridge filter.
So it works like the post filter.
Yeah, exactly. It is a post filter just in case you would have some biogrowth or biofilms in the tank, and then to avoid this not a pleasant smell in the treated water, we have to use the post filter.
Okay, thanks, Rosti. So while we start talking about the systems after, let's talk about the systems before the RO system, about the pretreatment. Rosti, what pretreatment, basic pretreatment we should use before the RO?
So first of all, when we talk about the commercial ROs, in many cases, we would use pretreatment. I would say in 9 cases out of 10, there would be pretreatment before RO. So it would be either a sediment filtration or activated carbon filtration, softening. Maybe in some rare cases, like 1 of 10, we would have just RO filter. In that cases where the water is quite good, but this is quite rare. So normally we will have pretreatment. So this is first. Then second thing that we have to understand, if the RO filter would work 24/7, it means that our pretreatment should also work 24/7. So it means that we should go for the twin tanks or duplex systems, so that when the softener, let's say, if we have a softener as a pretreatment, will be in regeneration, it means that RO filter should be in operation. If we talk on the intermittent operation, so if we have, I don't know, 15 hours a day of operation, 10 hours a day of operation, then we could use a single tank. Because we know that, let's say, during the night, we have time to regenerate a softener, to backwash activated carbon filter. So this is first thing we should consider. And then, yeah, so this is the general approach.
Okay, good. So like the basic, we understand that like the basic pretreatment, but what about if we have some complex water, like if we have the hardness in the water, what we should do in this case? What pretreatment do you recommend in this case?
So if we have hardness, of course, membrane would handle the hardness. But if the hardness is more than 100 ppm calcium calcium carbonate, we should go for pretreatment. And there we have two options. So the first option, to put a softener, a regular softener with salt regeneration, or we could use the dosing station with antiscalant. So here we have the good question is what to choose, a softener or a dosing station. So the answer would be both. I would look at it from the technical perspective and also maintenance perspective. So a softener is a much more reliable way for pretreatment. So you put a softener, you have a brine tank, then a maintenance, people who do the maintenance on site, they just have, what they have to do, they just to fill salt from the back to the brine tank. And this is quite easy. The dosing station would require more sophisticated service team. But this should be a more sophisticated team on the dealer side. So this is one way of selection. Then from the technical point of view, so if according to our experience, if we are below 500 ppm of calcium carbonate, would have both. We have
Rosti, repeat please, because we lost you for some time.
When the water hardness is 500 ppm and lower, then we suggest to go for softening. And then in this case, we would have both. We will protect the raw membrane, and also we will extend the lifetime of the raw membrane. According to our experience, the lifetime would be extended at least by 2. If we are above 500 ppm, then we suggest to go to anti-scaling dosing, because you would have too much salt consumption in this case. And then you just have to select the right antiscalant, or we can help to select the right antiscalant. And then we will protect membrane by dosing the antiscalant. So if we, let's say we have the water with 400 ppm, and we would install a softener, according to our experience, the time between regenerations, between CIP, not regeneration, between cleaning of the membrane, would be 6 months and plus. So if we go for anti-scaling dosing for this particular water, then we would have to do CIP like once in 3 or 4 months. Oksana, we may also look to the questions from the chart.
Yes, I saw this is about microbiology, so that is why I'm waiting a little bit, because to be honest, this is one of our questions.
Yeah, Dutch water tap is good just directly. I think this comment does not require answers. But we will come back to the microbiology parameters a little later. So I will answer this question.
Yeah. So yeah, that's clear now about the hardness. But what to do with the iron?
Yeah, iron have to be removed. So if with hardness we have 2 ways. So we have either softening or anti-scaling dosing. So with iron, we have only one way. We have to remove it before RO. And then in this case,
it does not matter what the volume of iron in the water.
Basically, no. Well, some producers of the anti-scalant, they say that if you are below 1 ppm of iron, you could go for anti-scalant. If you are above 1 ppm, then you should go for iron removal. In our opinion, if we talk about the commercial ROs, not industrial ones, if you talk about commercial ROs, normally you do not make maintenance often. And normally you do not have sophisticated staff on site. So when you talk about the commercial RO, our experience says that iron should be removed in any case. Even if you are like 0.4 ppm iron, it should be removed before. Because you would most probably, you will visit this site maybe twice, maybe 3 times a year. And during this, in between these visits, yeah, the system should be in operation. So the best choice for the commercial ones is to apply Ecomix units, as Ecomix will reduce both iron, and Ecomix would also soften water. And then you would have a reliable operation of the RO, and also you would have quite a simple maintenance of such a unit. Also, in the case I have shown before, Ecomix is also good to reduce organics. So if you have organics in the water and hardness, Ecomix is also a very good solution. If the iron is quite high, in some cases iron could be more than 15 ppm or more than 10 ppm, then in these cases a combination of iron removal medias and Ecomix, or iron removal medias and special antiscalant, may be applied. So in some cases, when you have high iron and high hardness, so this is the most complete, as someone says, this is not a problem water, this is a problem water. So when you have a problem water, it is always nice to discuss with somebody what should be the approach. We like this kind of discussion, and we have quite a good experience in some Ukrainian areas and also in Europe on how to deal with the water that has high hardness and high iron. So you may come back to us as soon as you have these kind of cases. We will gladly discuss with you and suggest our solution.
Yeah, and thank you. And while you were mentioned about Ukraine, for example, in Ukraine, it is disaster with the chlorines in the water. So how to deal with this, how to save, how to protect the system if we have the chlorines in the water?
Yeah, in Ukraine, in every city, the water is chlorinated. And amount of chlorine is in between from 0.2 up to 0.8 ppm of chlorine in the water. And also the chlorine level fluctuates during the year. So it is also important to say that if your municipal water is chlorinated, also take into account that it can go up during the springtime, this especially March, April, and also the level of chlorine is going up during the summertime when the temperature is going up. Amount of normally the centralized water stations, they increase the amount of chlorine. So in this case, we, as a rule of thumb, we recommend to put activated carbon filter to any municipal water supply. So even if you come on site and you do the project and you don't have chlorine in this very moment, I would suggest to put activated carbon filter, because most likely you would have chlorine with time, and then you will just damage the membrane, and it would be quite hard to explain to the customer why you need to install activated carbon filter afterwards. And this is the way we do. For example, a good question of what kind of activated carbon may be used in these cases. So the answer is also not so straightforward. So if you have chlorine and organics, then you should go for macroporous carbons like Filtrasorb 300. And these are charcoal-based carbons, not coconut shell. If the water has only chlorine, so you do not have any cases for organics in the water, then you could select less expensive carbon. It would be coconut shell-based carbon that is quite effective to reduce chlorine from the water.
Okay, that's very interesting. Thank you, Rosti. So now the last question about the pretreatment in my list is, what about the microbiology?
Yeah, microbiology is first of all, microbiology is the most complicated case because it's quite hard to fight with it, and we should. My personal suggestion that if you have the microbiology in the water, first of all, you have to understand what is the source of that microbiology. And you have to be sure that the source of the water you have selected is appropriate for water supply, especially for drinking water supply. And this we have to be you have to be confident that there is no leakage of the sewage water in this type of in this kind of and in this particular way well you are using for water supply. And if you see that there is a leakage of the sewage water, maybe you have to select another source, because our goal is to deliver safe drinking water. And if you have the sewage water leakage, maybe it's impossible to do to supply the safe drinking water. So as soon as you are confident in your water source, but you still have microbiology, first we suggest to apply the treatment of the well. So there are many procedures. You may also, if you don't know one, you may contact us. We will provide you a written procedure that is recommended by many health organizations all around the world on how you have to sanitize your well before you start operation of the water treatment station. So when you do that, then you can go to the next step. So if you still have microbiology, then you can go to standard technique on how to fight with microbiology. So you put the chlorination, the dosing station with sodium chloride. Then you put a water tank, and then you have to make sure that there is a contact time of at least 1 hour to let chlorine disinfect the water. So let's say we have a water flow of 1 cube an hour. So it means that your tank should be at least 1 cubic meter, so that you have enough, so that there is enough time to disinfect the water. Then we put the pump station, then we put the activated carbon filter, and then you go to the reverse osmosis system. Then when we have the microbiology in the water, we should also care about the membranes. So first of all, in all EcoSoft membranes and in all EcoSoft RO units, there is a flushing mode that keeps membrane in good sanitary conditions. So if the system is not in operation, after 24 hours of standby, the system will switch on automatically and will do the forward flushing. So if you do have the microbiology in this case, you may decrease this hours up to 12 hours. So you have to understand that if you have the microbiology, the water should be the system should be in operation. Then you can apply the dosing station before RO to inject the biocides. So normally it can be done once a week. So you could set the station and then dose the biocides based on the it is called DBNPA. So this is I don't remind this is the abbreviation for the biocide, and then you do it once a week. And if you do all these stages in sequence, then most probably you would not have any issues with the microbiology of the permeate. So Oksana, there are some more questions. Let's go through them. Please give also some details regarding the membrane. We can check with conductivity before and. Yeah, so this is very good. This is a very good question from Marion. Thank you. And this is a very good basics of what everyone should know, and how basically the question is when we should stop RO and clean the membrane. So a general rule is that when you have a decrease of the permeate flow rate by 15%, or you have a decrease in the water quality of the permeate by 15%, so this is the alarm that you have to stop the unit and make CIP. Of course, when I say the flow rate is decreased by 15%, I mean that the temperature and the feed TDS is constant. But this is the basic approach. And why is it 15%? Because if you will go deeper with the flow rate, like by 20%, by 30%, then the CIP might be not sufficient. So maybe you will lose the membrane and you won't be able to clean it. And this is the way why we should stop when it's only 15%. In our IoT products, we measure this. So you see the IoT units, they have this connectivity where we measure water quality and we measure the flow rate of the membrane, and you may see on the graph how your parameters are changing. So it's very handy. You just look on the graph, and also you have automatic notifications that in this particular unit something drops down, and this is the signal to you that you have to do the maintenance. Everyone, I hope I have answered your question. Yeah, so TDF 15% is also for the TDS of the permeate. And then we have second question: when inlet water has 500 ppm of calcium carbonate, hardness and recovery 75%. So there is no straight answer to your question, because when we select the antiscalant, we take into consideration not only the calcium carbonate concentration. So so first of all, when we select when we calculate the recovery rate, and when we select the antiscalant type, we took into consideration the complete water test. Basically, calcium carbonate is the core parameter, but also pH influences, also the sulfate influences, and also the total TDS and the sodium concentration. So when we know the composition of the water, then we calculate the recovery. This is the right approach to calculate the recovery and select the right antiscalant. If we talk about the now I would answer in this way. So most probably, if you have this 500 ppm calcium TiO3 and you have the right dosage of Ecotec 1000, which would be around, I would say 7, maybe 10 ppm. So in this case, the membrane would work quite long. I can see the name of the guest, but if you have any further questions, please let us know.
Okay. Let's continue. So thank you, Rosti. Most of our customers there know that in our range we have some options for the commercial reverse osmosis systems, like the permeate flashing and blending kit. What is the purpose of these options? How can we use them? When can we use them?
So first, before answering this question, I would like to explain our logic on how we produce our units. So our global idea that we produce standard units. Sometimes we produce standard bricks that are always available on stock. And then out of standard units, we can build a tailor-made water treatment system. So in order to do that, we produce not only reverse osmosis units as a standard units, but also we keep accessories, various accessories and various membrane on stock, so that we can, at the time we get the request, we can combine these units into a tailor-made composition. And one of these units are the blending and permeate flushing kit. So this is one kit. I will now a little bit explain and then show some pictures. So the explanation why we need this kit. So there are, I would say there are 3 cases. So the case number 1, when we use it as a blending kit. Sometimes you need a permeate with certain TDS. For example, you do the water treatment for brewery, and they ask you that we need a TDS of 150 ppm. And then you take a regular RO unit, then you take a blending kit, you install it by yourself during the installation, and then you can adjust the mixing. You can adjust by this blending kit. You can adjust a ratio between the permeate and between the raw water, so that the customer gets 150 ppm of ppm TDS of the treated water. So this is first case. Then the second case, when you have a problem water, and you want the membrane to live longer before CIP. So in this case, we use a flushing, not with raw water, but we use a flushing procedure with permeate. Mm-hmm. Then you connect the tap water, and then you connect not the tap water, you connect the permeate. To this kit. And then when you have the flushing sequence, of course, you change the programming, and then you flush the membrane with permeate. And during this, what is important, during the standby, the membrane is soaked in permeate, and it helps to remove the hardness and other contaminants and from the membrane surface. So this was the case number 2, and there is case number 3. If you have lack of water on site, so sometimes you have enough water to produce permeate, but you do not have enough water for flushing. So in this case, you just cancel flushing with raw water, and then you enable flushing with permeate. You use this blending and permeate flushing kit, and then the system works great, even with the lack of feed water. Now I will share my screen. So thank you to our technical expert Vitaly Stetsenko, who I believe also online. So we have not only the blending and permeate kit, but we have also beautiful videos that explains. So this is the blending kit that is called PIMO 612. So 612 means that it's good for units for 600, for 6500 and 1200. Like, let's say it in this way, with 1 membrane and 2 membrane units. So this is the universal kit for 2 units. When you supply it, you receive a box with the solenoid valve, with the check valve, and with the flow meter. So then I will let it play so that you see what is. Now you see the screen, yes, right?
Yes, we do. Yeah.
So you got the complete set of all required parts and also brackets. Then, of course, you will need some tools, but standard ones. So this is the case number 2 and number 3. So when you need to use this kit as a permeate flush, so you either use the pump station, the one you have, or you may use a separate one. It depends on what kind of station you have, and then you connect the permeate. You connect it to this blending and flushing kit. Yeah, good news that you may read the manual, but also you could see the video. So in this case, you could select whatever you want. So as you see, it's quite easy to do this installation. So it is quite easy to make, to convert a standard unit to a tailor-made unit just on site. So every technician can do that. So I think that I will stop it here because everyone could see this video online and yeah, use it whenever you need it. And then we can come back to also, there is one more question, Oksana. What is the correct maintenance for the RO membrane that you suggest? For example, acid biocide after. What is the performance of the membrane after? So when you stop the unit for the CIP, so when you have this drop of flow rate, then you apply a sequence. Then you apply a sequence of chemicals, a sequence of cleaning to clean the membrane. So again, there are two ways. So there is a rule of thumb. That would say that what is the most often sequence? So it is consists of cleaning with alkaline solution and then with acid solution. So this is the majority of the cases. If you have, for example, silica in the water, then you have always start with the alkaline cleaning. If you have organics in the water and you have bacteriological contamination, then in between alkaline and acid, you use the biocide cleaning. You can also download the manual to our CIP station, and you can actually look how the performance look like, what is the equipment, and what chemicals we suggest to apply. And the question to the last part of your message, what is the performance of the membrane after? So if you have stopped the unit when the decrease was 15%, then the performance would be 100% of the initial one. Basically, when you do everything in the right way, you will lose 5% of the performance a year. Yeah, normally after 3 years of such sequence, operation, CIP, after 3 years, you change the membrane. So when you lose 15% of your performance. So this is the general approach. And then we have a question from Thomas. So what is the normal pH for the permeate water after RO? It is in the range of 5 to 6. So also a general answer would be from 5 to 6. Of course, it highly depends on the of the feed water, and the precise calculation can be made, and I can actually share it. I have the answer to this question in a table. You can look at it. Can you see the table now, Oksana?
Yes, we do.
So we made a calculation of the permeate quality. If you have this kind of water before membrane, and then we did the calculation in the software, in the Wave software, what would be the water quality after the XLE 4040 membrane and LCLE. So the straight answer to your question, so in this particular case, the pH would be 6 in both cases. And also, you may pay attention. I would draw your attention to the various parameters of the water after. For example, the TDS. So the XLE would provide you a little less than 200 ppm when the feed water is 2700. And you would have 92 after LCLE. So this is the difference. Also, thank you for the question that you have written to us before. It was the question on the chlorides concentration. So it was the question: what would be the? Is it possible? What should be the membrane to have if the chlorides is 530 ppm before, and the project needs to have the chlorides below 18. So the answer to your question that you would have below 18 ppm of chlorides if you would use LCLE membrane. So we have already made that calculation, and this membrane will fit your application. So I believe that the person who asked is online now.
Rusty, we have one more question from Dominic. And by the way, this is like in combination with my questions regarding the tanks after the RO system. What tanks we can use for the RO system, and then how we can make the remineralized water after RO based on this.
So first, after RO, there should be always a tank. A pure water tank for the permeate, and this is our strong recommendation, because the unit, the reverse osmosis unit, should deliver permeate to the tank, and then when we have various equipment, it could be dispensing equipment or hot water boiler or etc., it should be delivered by the pump from the tank. So this is a general rule. A very good question always appears: what should be the volume of such tank? Our approach is that the minimum volume of the tank should equal to our production of the unit. So let's say we have our production of the unit is 500 liters. So this should be a minimum volume of such a tank should be 500 liters or more. We do not recommend to make it less than 500 liters. And then when we come back to the question of Dominic, how we can remineralize water after RO. So there are actually three ways how we can do it. So the first way I have already described, it is blending of the raw water. So if the raw water quality allows you to blend this water to the permeate, for example, if you live somewhere in Netherlands and you have Dutch water, as we already know from the comments, then you could use a blending kit, and then you could remineralize the water with the feed water. This is a very nice way to do that. Then a second way, you may install a dosing station after reverse osmosis unit, and then you inject minerals just after RO before the tank. So the tank would make the concentration of the water equal. So it will commonize the TDS. And then you may inject minerals like calcium, you can inject magnesium minerals. So this is second way. And the third way, you may install a tank with the calcite or calcite plus Korosex medias. But I would also suggest to do it just after RO, before the tank. But one should be very careful with the Korosex, because if you will exceed the volume of Korosex, you would have, not even might have, but you would have issues with the pH. So be very careful with Korosex. So it's already 1 hour. We are. Yeah. Rusty,
just the last one, and it would be like the teaser for the our next session. I have the question about what trouble we might have when using and starting the system.
Yeah, this is a favorite question of our technical support colleagues. So there are, as Vitaly says, So there are three reasons why you may have issues during startup. So the first issue is lack of water. The second issue is lack of water. And the third issue is lack of water. And I think next time we will explain what we mean by this. I'm glad that Rick understands this, but normally when we start up the unit, we face the issue that there is no enough pressure or not enough water because of the small diameters of the pumps, because of the pressure loss on the prefiltration, and due to this, you spend much more time during the startup. And we will talk on this next week on how to prevent it, because we already know that, of course, there are other reasons. Yeah, there is reason number 4 and reason number 5, but they are so rare, so that we will draw attention only to this water question. And there is a question from Doug. Have you tried DuPont new membrane LCHF? Yes, we have tried it. We have tried low cost, high flow. It would provide the water quality like XLE, the water quality, but the quantity of the water will be lower. But we can also we could also make the calculation and also come back to you afterwards. We will add LCHF to this table and see what is the difference. Thank you very much to our guests for so many questions. I think it was the meeting with the most amount of questions. This is very good. Thank you. It is always nice not only to talk but also to answer.
Thank you, everyone, one more time. And yeah, as I already told that then our next meeting would be also about the commercial aero units, but we will talk about the troubleshootings and how to avoid them, of course. So next Friday, same time, we will be glad to see you. If you have the questions, so please forward us to them so we can prepare beforehand and answer them.
Yeah, have a good end of the day. Have a good weekends.
Yeah.
And see you next Friday.
See you next Friday.
Ага, we send meeting with you.